So we can start our discussion here with measures of central tendency, that is, measures of averageness, by using the most classic measure of central tendency, the one you're probably most familiar with, the one you probably think of when you hear the word average, the mean. Where the mean is just the sum of all the values divided by the number of values. That's what this little sigma here means, that capital sigma. That refers to taking the sum of all things of that form. We're not going to be very picky about that sort of notation. I think I've mentioned it before anyway, but just bear in mind that's what that refers to, just to be clear. It means take all of the things that are like our x values. There are things that we're considering in our data set, where, to be sure, we have a slight piece of notational specificity to consider that we call mu the population mean and x bar the sample mean, which probably looks a little bit unnecessary because those formulas look almost identical, except that one has a capital N, one has a lowercase n, and in this case it doesn't really make that much of a difference except to be sure about what we're discussing. That if we have all of a population, it's great and we can talk about all of the population, but usually we don't. And in statistics in particular, we often like to use Greek letters for reasons I don't fully understand to refer to population things, and more English-style letters, maybe with some accents in there, to refer to sample flavor things. Here, there's really no difference in the formula, but it is important for the sake of context to know that one is not precisely the same as the other. It's a matter of what we happen to be discussing with the problem. Anyway, let's actually take a look at a problem so we can confirm to ourselves that we do know how this sort of thing works. So for this example, we have a surveyor that collected the heights of a class of third graders at the zoo. The data is as follows in inches. We've got those heights as given, and one should stick out just a little bit. We want to compute the mean for the data set. So first thing we should pay attention to here is we're looking at the heights of third graders at the zoo. It's a little bit silly. I don't know. Sometimes surveyors have to be a bit opportunistic. It can be hard to get into the classroom, although that's making some implication with surveyors that don't want to. But, well, you got to make it work. And in this case, we're going to treat this as a sample of third graders. So if we want to get the value for x bar, that sample mean, what we would have here is all of those heights, 43, 44, another 44, 46, and, well, so on down the line until we get to one in particular that, like I said, should jump out just a little bit there at the end at that height of 168, which we're going to divide by 9 because we have 9 of these things. So that's what our sum x, that's what that sigma really refers to, is the sum of all things like that. In this case, those are heights of third graders, which will give us a value here of 60.2 inches on average, which tells you that the height of third graders based on the sample is about 5 feet. And I've met some tall third graders, but still, that's a little bit much. And what you should probably pay attention to here is that guy. Well, not really guy. Technically, because the surveyor wasn't very scrupulous, wasn't very careful at their job, and unintentionally ended up also recording the height of a giraffe in with all of that sample data. Not always the easiest job and doesn't always attract the very best workers. Where here, hopefully, this also indicates something important about the mean, that while it's the traditional measure of what we consider an average, it can also be somewhat easily affected by unusual data points, things that in other contexts we would call an outlier, but that we're not going to properly define here because that takes a little bit more machinery than what we're going to get to. Point is, when we're dealing with the mean, it is very useful, it is very commonly taken as the standard, but it does have its flaws. And one other thing we can do with the mean is what we're going to look at next, where we talk about the idea of what is called a weighted mean, in cases where certain values might have amounts associated to them in particular that we need to take into account when we are looking at things of this nature.